Right, okay, you're 13. What we're going to move on to now is we're going to move on to the last section of 6.6, which is hormones, homeostasis, and reproduction. So we're going to spend the next few lessons focused on this part of the topic. Today, we're just going to look at the endocrine system and the glands that make up the endocrine system. So within your body, there are there's many different ones. You can see on here there's the key endocrine glands which are a part of the body. So you've got like the two in the brain. So you've got your number one is pineal gland, two is pituitary. You've got your thyroid, your thymus. Then you're coming down to your adrenal gland, your pancreas, and then ovaries if you're a female, and then testes if you're a male. So all of these secrete hormones, and they are secreted directly into the blood, and they are carried to target tissues where they'll bind with the top. Remember, they'll have protein receptors in there, which will be the target cells, and then the change is monitored through feedback. So most hormonal changes results in negative feedback, which means that it shuts off the hormones. The hormone will be produced and it will shut itself off by having an intended action. So these are your key endocrine glands it mentions there. Your thymus, probably a little bit more contentious. You may want to look that one up, but that's more to do with T cells, but it's included in here. Just change as you get older. So as you get older, it shrinks. But we're just going to have a look through the key ones. The ones you probably know about would be your ones involved in blood glucose. So you have two hormones involved in that, insulin and glucagon, and these are secreted by beta and alpha cells within the pancreas to control blood sugar. So you're probably quite familiar with insulin and what happens via diabetes, that if let's say you've eaten lots of sugary stuff, the receptors in the pancreas will detect that, then they'll secrete insulin. Insulin will go into the bloodstream and encourage the liver and also the muscle tissue, skeletal muscle to take up that glucose, which is in the bloodstream, and convert it to glucagon. No, glucogen, sorry. I get confused between the two. You think they could have named them differently, don't you? Glucagon and glucogen. So it's stored in the body as glucogen for when you need it. Now, let's say your body then runs low with sugar. It'll be detected by the pancreas again. The alpha cells in the pancreas release glucagon. That will then go into the blood, and that will tell the liver to release the glucose into the blood along with skeletal muscles, which have got glucagon in them. A glucogen in them, which will then release it to glucose, and that'll increase the blood sugar level. And then, because the blood sugar level has gone up, it will then decrease production of glucagon. So to see how it like feeds back and stops it from happening. Okay, so that's how it's going to control it. I'm going to have a go at trying to answer in that question, explain the control of blood glucose. There is an answer for that on the thing. So diabetes is one of the things that will be associated with insulin, and there are two types. Type 1 is early onset. Now, there may be a hereditary link. We're not really sure. It's kind of a weak relationship. It's more like an autoimmune disease, which leads to the beta cells being destroyed, which means insulin production will be low or it stops completely. So that when the body produces, well, when you eat lots of high sugar stuff, then your pancreas might detect it, but it doesn't produce enough insulin, which means the glucose level doesn't go down, and that can have a lot of damage on the body. It can damage a lot of cells, and obviously the health effects of that is ultimately death, but you have other things like having to have limbs amputated, poor eyesight, troubles with your blood vessels. It's not a great disease, but it can be controlled by insulin, and we'll look at that tomorrow. Insulin injections. Type 2 used to be seen in people generally over the age of 50, but as people have got probably lazier and fatter, then we're seeing more of this happening. Now, there is a strong relationship to genetics here, to hereditary, and like I said, it's related to obesity and poor diet. So what happened is it could be either you've got fewer insulin receptors in the liver, or your body is less sensitive to the insulin, which means the insulin doesn't have effect on those target cells. Those target cells just miss the message, so they don't take up the glucose from the blood. So there's obviously a problem with that. We'll look at that more in detail tomorrow. The other hormones that we need to know about is thyroxine, which is in your thyroid gland, which is in your neck. and this increases your metabolic rate, so it increases respiration. So it's involved in your metabolism. So what happens sometimes, I think if I've got it better on another slide, is if someone's not getting enough not producing enough thyroxine, they can suddenly start putting on weight. So if you've got less thyroxine supported by the thyroid gland, the metabolic rate decreases, which means you've got reduced respiration of your brown adipose tissue, so you get unexpected weight gain, and more calories are stored as fat. So that can be a problem when you're not getting enough, if your body's not producing enough of the thyroxine. So basically, your hypothalamus in your brain detects this, sends a message to the thyroid gland. The thyroid gland either secretes more thyroxine or less thyroxine, and it all depends on the metabolic rate. So it's all to do with your like body temperature, because if you've got a high metabolic rate, you're going to be producing lots of heat, and obviously you don't want your body being too hot. Whereas if you are quite warm, then you're going to secrete less thyroxine. And there are like health effects that if you don't have enough, then you take thyroxine tablets to make your thyroid gland more or less active. So some people have an underactive thyroid, some people have an overactive thyroid. Leptin, this is associated with, could be associated with obesity. We found some stuff within mice. We'll look at that in a second. But basically, your adipose cells, they produce this to like lower your appetite. So if you've got an increase in adipose tissue, it means more leptin's put into the blood, which means you don't really feel like eating, and then helps to reduce your food intake. So in the 1950s, or 1949, effectively, they found that there was a mutation in mice, and that means they became profoundly obese. And what they did is they put into these mice, they treated them with leptin, which saw them lose weight. So they thought, well, maybe we can do this with humans, but the trials failed. So most people generally have high levels of leptin. And if it was linked to leptin, most people had a problem with the appetite control center rather than so it didn't actually respond to leptin. No one really lost weight, and quite a few people experienced side effects, like it says there. So obviously, the treatment for obesity goes on. There's hopes there would be a link there with possible treatment. And then melatonin, which some of you may have taken, you can buy in health food shops here in Hong Kong. Can't buy it in the UK though. And basically, your pineal gland will produce this in darkness. So in darkness, you'll produce the melatonin, and it's there to synchronize your circadian rhythms, so helping you sleep timing and blood regulation. So basically, when you're asleep, you produce this, and when you're awake, it goes down. So when you are going from let's say you're flying from one area to another, one country, if you're going on a long flight, you've rapidly moved time zones, and your brain's like trying to work it out, so you can end up with jet lag, which I'm sure some of you had at some point. Now, if people take the melatonin, they take the tablet just around about close to sleep time, it should help to alleviate those symptoms and help to reset you. Obviously, planes and stuff do this now by looking at they look at the light levels, and they try and get people to eat at the right time, so it's all feeding into your circadian rhythm. So your body will then start associating what time of the day it is, and like if they make the cabin dark, they're trying to get you to produce this this melatonin, so you then are thinking you are on the new time zone. And they're all different things that we're trying to do to get your body used to it, but that is another hormone that we need to know about in the case of this topic. Another thing I didn't mention about insulin is how we found out about treatment with diabetes. We actually removed the pancreas from like dogs, and then tried to see how long they could live for by giving them injections of insulin. One of them managed to last 70 days, which is amazing, but that's how we kind of found out what we could be doing to treat insulin. Anyway, so that's by the by. What I want you guys to be doing today is I have put a booklet. Now the booklet can be found online, but I've put it into Google Classroom. Now some of the stuff that's in there you will have done previously. So like when you're in GCSE year, so when you open it up, you're looking at homeostasis. Yeah, you know what homeostasis is? Homeostasis, keeping things the same within the body, trying to keep things the same, and hormones are involved in that along with the nervous system. So maybe come out with a definition of hormone, antagonistic hormones. Think about antagonistic muscles, they work against each other. Where have we mentioned something about antagonistic hormones today? So some of this, if you get it, you don't need to fill it in. You'll have done this bit at GCSE. If you can't remember it, fill it in. If you can, if you think, oh, actually, I don't need to do that, that's fine. I do not mind. There's no point going back over stuff that you already know. Okay? So you should know why we need to keep all these the same within the body. And obviously, it's not just about like things getting too high, it's things getting too low. So if your blood pH went too high, what would happen? If it went too low, what would happen? If you had too much oxygen in your blood, what would happen? If you had too much, not enough oxygen in your blood, what would happen? So all these things, don't just think about one extreme. You are trying to keep things the same, and they'll always be going up and down, rather like a thermostat. Okay, so fill all that lot in. And then what I really want you to be doing is going past all this and going down to page, actually we'll miss that bit out, and we'll go to page 8. And I want you to read through these parts, and then I would like you to just fill in the questions that follow about thyroxine, about leptin, and about melatonin. Okay? I know I've gone on for too long there. That's probably my longest video I've done. So if you've made it through this far, well done. Gold star to you. Thank you.